Hi, my name's Seb Rose and I am a BDD advocate with SmartBear. So you may think that I'm going to be trying to sell BDD to you, but I'm really not. This session is about trying to equip you with the knowledge of what the difference between test automation and behavior-driven development are, so that you can make informed choices about which are important for your organization and which might be useful for your teams. So we're going to first off sort of set the reason for the segment in the title, the subtitle that says interactions over tools. Then I will define test automation and behavior-driven development, compare and contrast them from a number of different angles. Finally, talk about the confusion between test automation and BDD that I've seen across the industry over the past 5 years or so, and then wrap up with some takeaways. So, without further ado, I don't know if anyone has read Ursula Le Guin. She died a year or so ago, a very famous American author, and she had an idea about names being really powerful. So if you knew the true name of something, you could control it. And I think really, what I'm trying to get to is, what does BDD, the name BDD, the name behavior-driven development, what does it actually mean? What does the name test automation mean? And are there other names that we really need to understand their meaning before we can have even a meaningful discussion about the difference between BDD and test automation? Also, read some of her books. They're great. Naming, though, is really hard. This is a reference to a gentleman called Arlo Belshi, who wrote a series of very influential articles a number of years ago and has recently rewritten them about the 7 stages of naming. Names are important because they are the place where we communicate our insights and intentions to other humans. And this is a really important point, because when you come to write a computer program, the computer doesn't care what name you give it. You could give a variable the name X or I or test 5. Computer doesn't understand what those mean. It doesn't care about them. However, it's people that read software as well to maintain it, to try and understand what it does. And therefore, we have to really treat names as important elements of our software. And therefore, it's important to understand the context of names, how we got them, what they mean, and to make sure they're not ambiguous and that different people are understanding them in different ways. BDD is a case in point, because in fact there are a number of other approaches to developing software which are in fact identical to BDD. So there's acceptance test driven development, ATDD, there's specification by example, and these three approaches to delivering software are identical. They just have different names. So we didn't do a good job of naming these processes. But once these names get out there into the world, it's really hard to delete some and merge them back together again. An important lesson, if one is needed, that you have to get a good name to start with, because as soon as you start releasing names out into the general public, they will live on. Behavior-driven development is an approach that only works for teams that are following an agile way of working. And therefore, the elephant in the room is, what is agile? What does it mean? The Agile Manifesto was written 2 decades ago by a bundle of guys that went on a retreat up in a ski resort. They came out of that weekend with the word agile and the Agile Manifesto, because it was the term it was the least painful term that they could all agree on. So none of them particularly liked it, but it was the one that nobody really, really hated. Agile, from an English dictionary, means about being able to bend and move fast and all of those wonderful things that you get from gymnasts and sports people. If you look out there in the agile community these days, it means way different things to different people, all the way from what you might characterize as the softer side of agile, where people are talking about important things such as safety, through to bits of agile that look quite similar to some hardcore processes from the last century. I'm thinking of processes like SAFe and DAD. So what does agile mean? Well, the only agreement that we can ever really get to is that it was coined and brought into the parlance of the software industry by the Agile Manifesto. And therefore, it's the Agile Manifesto that has to be the basis of any shared understanding of what Agile means within the software industry. One of the statements that was made in the Agile Manifesto was that we have come to value individuals and interactions over processes and tools. And this is where the subtitle for this talk comes from. I want to talk about interactions of people involved in specifying, delivering and maintaining the software rather than the tools that they use. This might seem strange because I come from the Cucumber open source project and Cucumber is a tool that was built to support behavior-driven development. And I don't want to get hung up in tools, so I'm not going to be talking about Cucumber. I won't be talking about any of the tools that SmartBear produce. I want to concentrate on the interactions that you will see in behavior-driven development between different disciplines and different people on the team, and the interactions that you will often see within teams that are practicing some form of test automation. And so this is a perspective that's important. So we've come from naming all the way through to perspective that is aligned to the Agile Manifesto. And at that point, this is me sort of setting the context for how I'm going to present this session. And I'd like to define test automation, or at least give a working definition that even if you disagree with it, we can use for the remainder of this talk. And of course, why not? Let's go to Wikipedia. So test automation is the use of software separate from the software being tested to control the execution of tests and the comparison of actual outcomes with predicted outcomes. Okay, so we're basically saying we're going to have some form of software that will automatically execute some scripts against the software that we're building and ensure that it behaves in the way that we expect it behaves. This is a really broad definition of test automation, but I think we need to start with a broad definition of test automation because actually it really is broad. Everything is considered test automation if it's a test that gives you information about how the system is behaving and it's automated. So penetration testing can be automated, load testing can be automated, usability testing, some of that can be automated. So there's a really broad scope of ways that you can, of tests that you can run against your software that can be automated. And therefore, this very broad definition of test automation seems appropriate. But let's think about the benefits. So rather than stick to the dry definition, let's think about what do we want to get out or what do we expect to get out of test automation. So because we generally contrast test automation to manual testing, we think that we will get faster feedback, or at least we hope that we will get faster feedback from automated tests. That's because a computer's running those tests, so you would expect the computer software to run faster and more predictably than an individual reading through a test script and trying to type in the relevant pieces of information into whatever the UI or however the test is going to be run. We also expect to get more frequent feedback because rather than having to spin up a group of testers or schedule a group of testers to test a block of software, because the automated tests are sitting there in your source control system and they can be run by your CI system, you would expect those tests to be runnable on a regular basis, certainly daily, maybe many times a day. Maybe we would also think that automated tests will get us higher quality. I think I'll probably show on the next slide that I don't believe that's the case. We would also think that we will get repeatability from those tests. And well, we will get repeatability from automated tests. However, is that a good thing? We'll talk about that in a minute. And finally, there's a hope across the industry that automated tests will be cheaper than manual tests. And I guess the thinking behind that is because there will be software that you can just run over and over again rather than having to have lots of testers going through the scripts manually and running them on a regular basis. I think that's also often questionable. So having thought about what some of the goals are, what the benefits we would like to get out of test automation are, let's think about what some of the challenges might be. So I think probably the first and biggest challenge is some test automation skills. So here there's immediately you're going to think about, well, can I write in a programming language? Do I know how to use Selenium to drive a web interface? And elements of a technical basis. But there's also other skills that even if you can code and you can drive the software under test, you got to think about, well, how maintainable are those scripts going to be? How valuable are they in actually addressing risk and helping learn about whether the software is of sufficient quality to release? These skills are in short supply. There's been a growing number of testers who have development skills, which is great, but that in itself is not enough. We need to have skills that understand that a test script needs to be maintained, that it can't keep breaking, and that we need to make sure that we don't unnecessarily duplicate test scripts because it seems like the computer is running them and therefore they are cheap to run. Well, actually, as many of you will no doubt know, automated test scripts can build up very rapidly to such a level where running the test suite can take hours, if not days. There's another challenge to test automation which is around testability. So the software that we are building is often not designed to be testable, and that then pushes us to testing the whole chunk of software all at once, which makes the tests run very slowly. It also forces us to generally go through the external interfaces. So we'll be always testing through either a service layer or a user interface layer. And these can all be challenges to writing small, maintainable, reliable, fast automated tests. This is a challenge that shouldn't be underestimated because in general, testers can have very little, in many structured organizational structures, testers have very little impact on the testability, the design, and the architecture of the software that they are challenged to test. The other problem, or another problem that you get with test automation is late feedback. So the software is already built by the time you run the automated tests. Now, the reason I'm showing this piece of burnt toast is because a very wise man called W. Edwards Deming talked about quality many decades ago. And he said, let's make toast the American way. You burn it, I'll scrape it. And I'm afraid that test automation plays into that view on quality, which is that we can get the developers to build the software, and then the testers will somehow run these automated tests, and that will scrape the burnt bits off, and make that software of a suitable quality to release to our customers. And that late feedback, that effort of having to do the scraping, if you like, that's expensive because you have to then throw the software back over the wall to the developers and say, no, you've got to fix this. And then we have disagreements about, is it a feature, is it a bug, who's misinterpreted the specs, and so on. Late feedback feeds into costs. And then finally, overconfidence. As I was putting this slide deck together, I immediately thought I wanted to use this image from a movie called Kelly's Heroes. Then I was speaking to a few folks and they said, well, many of your audience may never have seen Kelly's Heroes. Well, it's a movie with Clint Eastwood, Telly Savalas, and Donald Sutherland, and many other classic character actors. But the reason I've got this one is because they wander into a minefield. And what they end up doing is one person obviously triggers a mine, which is unfortunate, and dies. However, what the rest of the outfit have to do is they have to find where the mines are using bayonets, and then as they move towards getting the exit from the field, if you like, they can then walk over the same path that everybody else has walked over. And this is one of the problems of automated tests. Once you've automated them, is that if they're passing, it just tells you that the scenario that you've automated passes. If there's some areas that you have forgotten to write automated tests about, then the fact that all of your automated tests are running green only gives you information about the scenarios that you considered. And you may be confident that the software is ready to release, but unfortunately, that confidence might be misplaced. Now, the interactions that a test automation, an organization or team that are writing automated tests follows, I'm going to go through those. But before I do, I want to say that this is a total simplification. So test automation is such a general term and covers such a broad number of different ways, different tests that could be written by different teams for different domains, that I can't possibly generalize for every situation. So if you're writing automated tests, you may say, well, these interactions that Seb's talking about, that's not what happens here. I'm going to try and make it clear where the generalizations are as we go through, but basically I'm going to start off with an apology. It probably won't be right for you. I hope it's right enough. So we start with the business. So this could be a customer, it could be the product owner, it could be a business analyst. It's people that represent the views of the customer, that represent the idea about what the product ought to be doing, what functionality it should deliver, how it should help the user. And they will come up with some requirements which will then be passed to a technical team who will see how it fits into the architecture, the design, who will then go, here's the specification, and give it to the test automation team and also to the development team. So here I'm saying development and testing. I'm hoping that we've got an agile team. It's cross-functional. It's got developers and testers in it, so that in sprint there is some testing going on. But what I typically see is that test automation is done, if not outside the team, certainly at a different pace. So we don't do development and testing and test automation sort of hand in hand. They're not done together by the same people. And then the developer will go, here's the software that I've written to satisfy these specifications, and pass it over to the team that have been writing the test automation. And more often than not, the test automation team will run their tests, and something will be wrong. And we might go around this loop a number of times until we get to the point where either the automated tests verify that what has been developed works as expected, or we understand that there is a discrepancy and we have to report it back to the business. Here is some outstanding issues. Do you think that this is ready to release? So this is a typical cycle. Like I said, there will be many other ways of people interacting, but the point here that I think that I want to emphasize is that in many traditional organizations, it might not be waterfall, but there is definitely a flow of information from one silo to another. And test automation is frequently a discipline that is outside of the development team, and therefore not working closely, collaboratively together, but rather passing information backwards and forwards, possibly through tickets in a tool such as Jira. So at that point, I've talked about test automation. Behavior-driven development. BDD has typically and historically been hard to define. Over the past few years, the community has sort of settled on defining BDD as three interlinked practices. There is discovery, where the business, the development team, and the test team, here we would include the test automation team, create a shared understanding of the requirements through collaboration. We use an approach called example mapping, which you will find documented on the internet very easily. This discovery session is often also called the Three Amigos meeting. So the expected output of the Discovery Three Amigos meeting is a set of concrete examples that illustrate the business rules that a particular user story needs to implement. Those concrete examples then get formulated into some format that is readable by the business. One of the most popular formats is called Gherkin, and it uses the given, when, then keywords to capture the concrete examples. And that documentation is then interpretable by tools such as Cucumber, SpecFlow, Behave, and many others. And it will take the business readable specification and actually run those specifications against the software as it currently stands to verify that the documentation correctly describes the behavior of the system. And if it doesn't, then we know that either we've introduced a defect, or something's broken, or we haven't done that piece of work yet. What I would like to emphasize here is that these three practices, discovery, formulation, and automation, are applied to each user story, but not necessarily, but definitely not to all user stories at once. So you don't take all of your backlog and do discovery on the whole backlog, and then do formulation on all of the concrete examples that are discovered for every user story, and then do all the automation. This is part of the agile process. We will do discovery on a user story when we're happy that we've arrived at a shared understanding and captured enough examples to illustrate how it should behave. Then we will formulate for that user story, and then we will automate for that user story. And we may be doing discovery and formulation for other user stories in parallel. So what are the benefits? The benefits are, because discovery is a collaborative activity where we try and understand a user story by finding examples that illustrate its behavior, we learn early. We learn early if there's ambiguity. We learn early if business is asking for something that is difficult or hard to do. We learn early if there is no possibility of testing this. We learn a lot of things early. This is part of the shift left process. We are definitely getting ourselves into a position that we have ironed out a lot of the things that would often cause problems in software late on, close to delivery, before we even start writing any software, or before we even start implementing the code that will satisfy this user story. That shared understanding also comes out from learning this. Because we are talking in the same room, or in a virtual room if we are distributed and not co-located, we will be talking between the business, the test and the developers, and including UX potentially, security professionals, and anybody else that has an interest in the particular user story that we're talking about. And because you're having that conversation, when you come out of the discovery workshop, with those concrete examples, and the learning and the understanding is in fact shared between different disciplines. And this is a huge benefit, because we don't get into that tit for tat discussion between, for instance, a test team and a developer team, where the developers say, this is what was asked for, and the test team go retort with, that's not what we understood from the specification. But by the time we leave the discovery session, before we do any code writing, we've got a shared understanding that should persist for the lifetime of the product. Again, speed of feedback is important. Because we're working in the discovery space, we're getting feedback immediately about whether it's understood, whether the story's too big or too small. As we formulate these examples into business terminology, we get feedback from the business about whether that the terminology that we're using is in fact business terminology. We get feedback from testers and developers and the delivery team about whether those terms are sufficiently distinct to be able to be implemented. And we get feedback from the automation. Immediately we write it. Before we've written any software, we get feedback from the automation code that says, you haven't implemented this software yet. The software doesn't behave as you've specified. This is a great piece of information. That then becomes living documentation. Living documentation is a term which whole books have been written about. But effectively what we're saying here is that the formulated examples, they're written in the business language and can be understood by customers and business people. And we can have confidence that the documentation is correct, because not only is it readable by the business folk, it can also be automated, and then we can verify that it actually describes what the software does. This is this is brand new, really, for most teams. In general, most documentation is extremely poor and not reliable. So living documentation is a huge benefit. We also get better quality. We get better quality because we have already done a lot of learning through discovery. We have agreed on the terminology that we're going to use through the formulation. We have specified how the system should behave in the automation. And at that point, we are driving out the architecture of the underlying software. So it's actually when we write the automation code that we design the software's interface. And it's at that point that we can get feedback before we've written the software about whether it's going to work, about whether that interface is a suitable one. We also have an ability to do early and frequent refactorings because that automation will keep the software working. Once we get the automation running green, passing, then we can make changes to the interface to improve it, to add other features as it comes around, as they become needed, and the quality can be assured because that automation is always there for the development team to run. So this automation is owned and is important to the development team. And finally, this does lower costs. The costs are lower because we don't have that rework that the burnt toast late feedback leads to. We have different costs, it's true. We've front-loaded the costs in discovery. But the evidence, or at least the feeling of the industry, is that the shift to the left of doing the learning early and not committing mistakes in code until we've actually been through and learnt about the system that we're trying to develop does reduce costs. And in fact, in teams that I've worked with, it has reduced costs massively. However, to get to this point, because these are a lot of good benefits, just one on its own would be quite substantial. But if you get all of these, then you're really in a good place. There are some challenges, obviously. And the biggest challenge by far is that there has to be a change in working practices. There's no space now for a product owner or business analyst who won't talk to the team, who won't collaborate, who won't be there to answer questions. And actually, even if you have every iteration, you have a sprint planning or backlog grooming session with your product owner at the moment, that also is not sufficient. So if you think back to early agile methods such as XP, extreme programming, there they required an on-site customer. What we have seen work in place of an on-site customer is a daily discovery session. So if you read Matt Wynn's introduction to example mapping online, you'll find that he suggests 30-minute discovery sessions, no more than 30 minutes, and that the example mapping should take place every day. Some teams find that that's too many times a day, but actually the best way of working in my experience is you have a slot directly after stand-up every day, and at that point you pick a story, either one that you didn't finish working on yesterday or a new one, and you go through a 20 to 30 minute example mapping session. These changes in working practices are quite, they're not substantial in the greater scheme of things, but they are from within an organizational perspective, and this is a huge challenge. There's also the tooling in the BDD to support the BDD process is quite immature. So for instance, if you look at Jira, for instance, there are a few things that plug into it that claim to help you with behavior-driven development, but they only help you with, typically the tooling at the moment helps you with writing the given, when, then gherkin and integrating that with Cucumber. There are projects afoot to try and provide a more full integration with the behavior-driven development practices of discovery, formulation, and automation. SmartBear is working on one called Cucumber Studio, but we're not there yet. And then the final challenge is that the test automation world, the world of what needs to be tested, is massive. There's a huge Milky Way of different tests that can be run, and many of them that ought to be run. Behavior-driven development really does focus on functional tests, we're talking about tests that talk about the behavior, that look to the behavior of how the system should act. They don't really lend themselves to load testing or security testing or usability testing. So even once you've changed your working practices, made yourself comfortable with the tooling that there is, there's still all the other tooling, the automated testing that you would probably still want to do as in part of your in your continuous integration pipeline. The interactions of BDD, I'm not doing them in the same way. So this is a diagram that came from a book that myself and Gaspar Nodge wrote a few years ago called Discovery, which you can find at that website. But I also took this section out of the book and put it on LinkedIn. And so that's the link on the right-hand side of the slide. But I'm going to try and show you through this sort of 8-step process where the interactions happen. So it's the business that pick the next user story. So this is prioritization. This is definitely business's job, possibly with some input from the technical team about what would be most efficient for them to prioritize. The 3 Amigo requirement workshop includes everybody. So we need to have full collaboration there, because this is where we do get to the shared understanding. This is where we generate the concrete examples that are going to help guide the whole development process. Everybody formulates these examples. Everyone can formulate these examples into a given when then format, or whichever format your automation tool uses. We frequently find that actually it's just a pair of people that will do the formulation, and that would be, we would suggest that would be a developer and a tester working together, and that would then be reviewed by the whole team. So it's not enough for people just to go, oh, it's been formulated, that's okay. This review process is really essential. Let's compare BDD and automation is done by developers, or developers and testers together. Implementation is done by developers and testers together. Supplementary tests, some of those will be done by testers on the development testing team, and others will be done by dedicated test automation teams such as performance or load or security testing externally. And at this point, I think it's worth revisiting the green key on the left where it says development and testing now. I'm going to change that to say delivery team, because actually here we're talking about the cross-functional team that is responsible for delivering this piece of functionality. Let's compare BDD and TDD. So, behavior-driven development incorporates discovery, which is collaborative. It incorporates formulation, where we take the examples that come out of discovery and turn them into business language specifications or examples. And this is another collaborative process, and it builds on the shared understanding. And then there's automation, which is done by developers. So the test automation, the automation of the scenarios that come from the concrete examples is done by or with the developer's assistance, because this is the automation that's going to drive out the coding. It's going to guide the architecture. The automation also builds the living documentation, because by linking the business readable specifications to the software with automation code, we can make sure that the documentation remains up to date and correct and reliable. But other testing is needed. Test automation, on the other hand, is often done after or in parallel to coding. It's not done before the coding. It's often siloed. It'll be handled by a dedicated test automation team. It frequently focuses on performance and penetration testing, and the outcome, the scripts that come out of this are not necessarily business readable. So the overlap between BDD and TDD is automated business readable acceptance tests. And now the question, I guess, that's worth asking is, well, how many, what is the overlap like? How big actually is this BDD part of the Venn diagram? How big is this test automation part of the Venn diagram? And what does the overlap look like? This is much more how it is in the industry today. There's very little real BDD going on. There's a large amount of test automation happening. And in fact, actually, I think probably the green circle is still too big in relation to the blue oval. The overlap, though, is really small. So business readable acceptance tests is tiny. It's a shame because that's where a huge number of the benefits of BDD accrue. And I've tried to do an executive summary here because there are a lot of words that I've said so far, but to compare behavior-driven development and vanilla test automation, I've done this two-dimensional graph. So along the x-axis, we have applicable test domains. And that means what sort of testing does this approach lend itself to? And as I've said, test automation lends itself to lots of different test approaches, such as penetration testing, load testing, usability testing, and so on and so forth. Whereas the breadth of impact is on the y-axis, and here it's because behavior-driven development isn't just about running automated tests. It's not even primarily about running automated tests. Behavior-driven development is about collaboratively learning early, arriving at a shared understanding, crafting concrete examples that will illustrate how the system is expected to behave, formulate them into business readable terminology, which then when automated, not only drive out the design and the architecture of the implementation, but also turn those specifications into reliable, trustworthy, living documentation. So as you can see, there's a lot of benefits that you get from BDD. It really works best in the functional domain, about where it tries to specify and drive out the behavior of the system. The sizes of the circles here have no meaning. So in the previous slide, obviously, I was talking about sizes. I just want to say these circles here are just to mark the point somewhere in this two-dimensional space. And finally, let's move on to the confusion. First off, BDD is not the same as test automation. Test automation and BDD are very different beasts, as I hope I showed in the previous slide. Some of the reasons that we get to the point where people confuse the two, and I would say probably the biggest one, is the given when then words from the Gherkin language. Many people that follow a BDD approach will use a tool such as Cucumber, which understands this structure called Gherkin, which uses the given when then words to drive out, to capture the concrete examples in business readable way. And then people will start using Cucumber, and people have started using Cucumber to just write tests. So there are many test teams who will write automated tests using feature files that are written using given when then. And there's a belief that given when then is BDD. So as soon as you use Cucumber or SpecFlow and you write your test scripts using Gherkin and given when then, people think that they are following behavior-driven development. Behavior-driven development has nothing to do with given, when, and then. BDD is discovery, formulation, automation, and after the automation, then we design and build the solution. Working software is the goal. It's the goal of both test automation and behavior-driven development. The Agile Manifesto has another phrase in it that says, "We've come to value working software over comprehensive documentation." And for some people, then all of the front-loaded investment of discovery and formulation is unnecessary. Why are we involving the business? We're just writing documentation. We don't need all this documentation. The Agile Manifesto says, let's write working software. Well, working software is the goal of every software development team. BDD contributes to that. And what you get out of BDD is early understanding, early learning, and those benefits, those are the goals. The documentation, like the automated tests themselves, are in fact secondary outputs of following the BDD practices. And then finally, what do we do with manual testers? So manual testers are often thought to be unnecessary in the modern software development world. There's so much drive towards continuous delivery and test automation that some organizations have begun to think that if a tester can't learn to code or to automate, then they are no longer fit for purpose. And this is absolutely not the case. So the sections that I've marked here, requirement workshop, formulate, review, and supplementary tests, all of these require people with domain knowledge and testers' skills. So although it is very useful for testers to become cross-skilled in the same way that it's very useful for developers to cross-skill with test skills, it's absolutely not the case that you do not need those test skills, and it's absolutely not the case that testers who don't have automation skills cannot deliver value to your team. They absolutely can. So, time for a quick wrap up. Test automation has more applicable domains. It goes everywhere from making sure that the code that's been written delivers the functionality that the system, the business would like, all the way through to making sure that usability, performance, security, all of these things work. So test automation is widely applicable to a lot of different domains within the software quality space. But BDD has a broader impact because BDD works all the way from when you're beginning to arrive at a shared understanding, when you're refining the user stories, and it works all the way through to through development, through delivery, into maintenance. Because if you come back to a product after a number of years and you have to add a new feature, for instance, because there's a new regulation that's happened, well, the living documentation that BDD has created is still there, sitting in source control, and whether the old team is still available or whether you have a new team spun up that's going to do that enhancement, that living documentation will be 100% reliable, and the team will be able to get up to speed really quickly without having to try and reverse engineer the behavior from the code base that they find. I want to emphasize again that the fact that both BDD and test automation have automation aspects to them does not mean that testers without automation skills can't add value. They can add value. They will probably be some of the most valuable people on your team, and they will have a lot of domain and testing knowledge that you will need for years to come. Given, when, then are not discriminators. These keywords are facets of one way of capturing concrete examples in business readable terminology. But there are others. So please don't allow yourselves to be to think that just because you're using the words given, when, then, you are working in a behavior-driven way. And then finally, it's not an either or. I was comparing and contrasting test automation and behavior-driven development in this session, but that's not to say you have to choose between them. What I want is for people to understand that they are different activities. There is a little bit of overlap in the sense that there's automation in behavior-driven development and there's automation in test automation, but they are different activities that deliver different values, and the best teams will follow practices for BDD where appropriate and will automate tests without using Cucumber or Gherkin, possibly even without doing formulation for other areas of the domain. And I hope that made sense. I know I rushed through that, but it was a lot of information to get across, and therefore we have 15 minutes of live questions just now, and I will be very happy to answer any of your questions by email or on Twitter after the conference talk has finished. Thank you very much.